Hey everyone, so today we're diving into something that has totally changed the game in medical training. It's a way for doctors to practice for the absolute worst case scenarios without ever putting a single patient at risk. We're talking about patient simulation. Let's jump in. To really get why simulation is so vital, you have to start with this quote. It's pretty unsettling, right? It cuts straight to the massive ethical problem that medicine had to solve. How do you possibly train for a life or death crisis? Well, for a very long time, the answer was on real, living people. So yeah, let's take a look at that traditional, high-stakes way of training doctors. The one that basically forced the invention of something better and, a whole lot safer. For decades, this was the mantra of medical education. See one, do one, teach one. A trainee watches a procedure, then they do one themselves, and then they teach it to the next person. But this sink or swim approach was, well, it was incredibly inconsistent. It relied almost entirely on trial and error, on actual patients. Today, we look back on that and see it as just unacceptably risky. There had to be a better way. And that better way, of course, is patient simulation. It's this revolutionary idea that provides priceless experience without putting anyone in harm's way. So, what are we actually talking about here? At its heart, patient simulation is all about creating these guided, interactive experiences that feel just like the real world of patient care. The most important part is that it lets doctors and nurses feel the pressure, see the complexity, make mistakes, and then, critically, learn from those mistakes, all in a completely controlled and safe environment. And its use goes way beyond just teaching medical students. Hospitals use simulation to test their own systems. Like, how does our ER team actually respond to a major disaster? Let's find out. It's used to test new equipment before it gets anywhere near a patient. You can use it to assess a seasoned doctor's skills, or even to research how things like stress and fatigue affect a team's performance during a crisis. Now, when we say simulation, it's not just one thing. It's this huge spectrum of tools and technologies. Think of it like a giant toolkit with different tools for different jobs. And this is a really key difference. At one end, you've got what's called low-fidelity simulation. This could be a simple app on an iPad, or maybe a plastic arm that's just for practicing how to put in an IV. But at the other end of the spectrum, you have high-fidelity simulation. We're talking about incredibly realistic, full-body mannequins that can breathe, bleed, have seizures, and react to medications, all inside a perfectly recreated operating room. This is where complex team training, stuff inspired by the aviation industry's crew resource management, really shines. And that toolkit is just massive. It has everything from those computer programs and plastic arms to hiring professional actors. They're called standardized patients to play the role of someone who is sick or anxious. And now, of course, you've got virtual and augmented reality entering the scene, sometimes even blended with mannequins in these amazing hybrid simulations for the most realistic experience possible. And this training doesn't always take place in some fancy high-tech center. Sometimes the most valuable training is what's called in situ, meaning in place. This is when they wheel the high-tech mannequin right into a real operating room or a real ICU and run a surprise drill with the actual team on duty. While a dedicated center gives you total control, in situ simulation tests the real system with its real equipment and all its real-world quirks and problems. Okay, so we've talked about all this amazing technology, but here's the big twist. The most important, most powerful part of simulation has almost nothing to do with the technology. And this quote really gets to the heart of it. It turns out the biggest challenge isn't building a more realistic robot. The biggest challenge is finding and training skilled instructors who know how to guide people through the learning process. This says it all, doesn't it? This simulator, no matter how sophisticated it is just a tool. It's a prop. The real learning happens because a person, an expert facilitator, is there guiding the entire experience. So a typical simulation exercise unfolds in 3 parts. First, there's the briefing, where the instructor sets the scene and gets everyone comfortable with the mannequin and the room. Then you have the scenario itself, the intense, hands-on part. But it's that third step, the debriefing, that's where the magic really happens. A debriefing is not a lecture. It is absolutely not about the instructor saying, you did this wrong, and you did that wrong. It's a carefully guided, reflective conversation. A great instructor will ask questions like, talk me through what you were thinking at that moment. Or, seeing it now, what might you do differently next time? This process sparks this deep, self-directed learning that really sticks. And it's the foundation of concepts like Anesthesia Crisis Resource Management, which is all about teamwork and communication, skills you just can't learn from a book. Okay, so this all sounds amazing in theory, but what's the real impact? And where is all this technology headed next? Right? That's the million-dollar question. Does all this practice in a pheek room with a robot actually lead to better care for real patients? Well, researchers are all over this. They track the impact from the sim lab all the way to the bedside. Level 1 is just, do you get better at the simulation? Level 2 asks, okay, but does that skill transfer to real patients? And the holy grail is level 3. Do the patients of these trained clinicians actually have better outcomes? And the evidence is really piling up. Study after study shows that simulation training has a huge effect on skills and a very real, measurable effect on patient health. So when we look to the future, a lot of people's minds jump straight to virtual reality. And while VR is advancing at an incredible pace, the consensus is that it's not going to completely replace physical mannequins, at least not anytime soon. The future is much more likely to be a hybrid, a blend of the physical and the virtual, to create the best possible training environments. And all of this leaves us with a really fascinating question to think about. As these technologies get more and more lifelike, are we heading for a future where the most important lessons in medicine are learned not at a patient's bedside, but from a simulator?